Hello, everyone, and welcome. Now we're going to be coming to you live from a few different places as we carry this stream. It's a big day. It's a very big day in the world of PC hardware. Today we're going to be talking about the next generation of desktop CPUs, Intel's 11th gen core processors. It includes a whole new set of products from i5s all the way up to the i9 11900K. And along with all the new processors, we also have a new socket and a new chipset, and that means all new motherboards, the Z590 series. There's a lot to learn about these new products, and fortunately today I'm joined by two top-tier experts, Alex from Intel and JJ from ASUS. Welcome to the stream, guys. Thank you so much for joining us.
Thank you,
Thanks
JC.
for having me.
Appreciate it.
Now, okay, before we dive into the technical details, because I feel with both of you on tap here, we can get pretty deep. Would you mind just starting us off with the audience? What do you do at your respective companies? Your titles and the jobs that you do. Alex, if you don't mind, we'll start with you.
Sure. More than happy to do so. So my name is Alex. For Intel, I'm a tech evangelist and also community manager. But my background is in engineering. I was an design engineer for 5 years, and then I moved to the marketing side and social media, and thus I became a tech evangelist. And right now, I help our team when it comes to desktop and also mobile processors on the launch and manage everything, the communications and all that stuff. So thanks for having me here, JC. I'm pretty excited.
Right on. And JJ, I mean, we've done so many streams together. I want to start you off with a man who needs no introduction, but I think it's always fair to give you a proper introduction.
Thanks so much, JC. I appreciate it. And thank you for everybody joining us here on the stream. It's fantastic to be here again with Intel and Newegg to be able to talk about really an amazing platform, a really cool set of processors, and really just a lot when it comes to the PC DIY experience. For me, for those of you who don't know, I've been with ASUS now for about 15 years, a lot of different roles. And now currently really the focus is technical product marketing manager in North America. And I help to coordinate between our product marketing team and the community, help to do a lot of kind of community edification, insight, and kind of ultimately collecting feedback so that you guys have the best understanding of our products and our feature set, and ultimately hopefully help to collect your guys' feedback and bring that forth to our product design team so that we can keep making better products for you guys.
Oh, for sure. And I feel like this is one of those important first steps. We've got so many new products to talk about. That participation and communication between the PC building community and the manufacturers is always so critical. And that's one of the reasons why here at Newegg we wanted to do a bit of a live buying guide to help folks out there, decide which CPUs and motherboards might be the right fit for them. And also, it's just kind of nice. Almost all of these new products that we're going to be talking about today, we've got links down below on Newegg, so you can check out while the stream's going, or maybe if you're catching the stream in the replay. If you're looking to pick up something new, we've got that info down below this video. Now, before we jump into the conversation with you guys, I need to give all of the audience here a heads up that we will be giving away some fun prizes during the stream. You can check out the chat for details, but we're going to be hooking up 11 viewers with 11th gen processors, and a few of them with some Z590 motherboards. I don't know if anyone caught that. It took our producer Mike a second that it was 11th gen, 11 winners, 11 processors. We all had a good chuckle at his expense.
It broke my brain.
Math is hard.
It broke my brain.
Math is hard, absolutely. Mike has a lot going on in his plate right now, so it's okay.
I think to confirm, right? It's 1100 700Ks. Is that right?
That's right. We're doing the 11700s. So some solid hardware.
The link is in there for the chat. So hurry up, guys. Oh,
get on it. You're not going to want to miss this. And also, you'll be a step ahead of some of the replay crew. So because we're talking 11700s, we're talking an entire new range of CPUs from Intel. I want to start off with the Intel side, Alex. What should people know about the 11th gen core processors that are coming out now?
Sure. Thanks, JC. I'm more than happy to inform everybody, even though I bet you probably already heard about the news since the product, the product became public back in March 16. A lot of the features, but if you guys are just tuning in for the first time and just listening for the first time about the 11th gen processor, so one of the things that we have there is we have in there is a new core architecture. Actually, the processor is a completely new architecture. This is where we actually say thank you and goodbye to the Slack architecture. And now we have a definitely new architecture with new features. One of those new features is the improvement in instructions per cycle. So we have a new core, and this new core allows us to have a lot of actually 19% improvement in instructions per cycle, which makes it a lot more efficient, and it has a little bit of performance than our previous generation. It also, this processor implements, actually we brought our XE graphics architecture from the Tiger Lake. I don't know if you guys know that, which is pretty revolutionary, and we brought it over and we ported it into this processor. So actually, we expect the iGPU, so the integrated graphics in there, to be at least 50% better than what we had in our previous generation. Also in here, we have PCIe Gen 4, which comes with 20 lanes. So that means that you can actually have a by 16 card plug in there, plus your PCIe SSD, PCIe Gen 4 SSD in there. So that's pretty cool, directly attached to the processor. Let me see. And yeah, there's a bunch of other different features in there. So for those who like to overclock, there's a bunch of different, we'll dive a little bit that and later with JJ on that, but there's a lot of different knobs, and also we also have a thin die, just like we did for Common Link Edge. So we kept that thin die and the STIM, so the solder thermal interface in there, to help also to reach those high frequencies, which actually JJ and ASUS, congratulations on that world record. So it's pretty interesting. You could probably touch on that later on that. Yes, we also have on the memory side, on the memory controller, we have on the Core i9, we can reach 32 megahertz and Gear 1, and this other new knob, which is called Gear 2, which allows you also to reach higher frequencies, which allowed you to hit even higher frequencies on that, and we'll also touch on that later on with JJ.
Yeah, we'll be doing a cool demo definitely on that side. Yes.
So to give you a quick overview of the processors, right? So we have we have the case keys, right? So the case keys are what we call the unlock that you can overclock. So at the top we have the i9K, the i9, and the i9KF. The F stands for you don't have the actual integrated graphics in there, so the integrated graphics is completely turned off in there. So that's at the top. Then we have the i7, just again like the i9. So we have the i7, i7K, i7KF. And then we also have the i5, i5K, and i5KF. So those are the three SKUs that we have for our processors in there when it comes to Rocket Lake or the 11th gen Intel Core processors.
And Alex, not to interrupt there, but just for clarification, right? i9 and i7, right, are both 8-core, 16-thread parts, right? And they both feature the same amount of smart cache, right? 16 megabytes?
Exactly. Thank you. Yes, you're completely right. So yeah, that's a great point. So both of them are 8-core, 16 threads, and the i5 is actually 6 cores, 12 threads. The difference, one of the difference between the i7 and the i9 is when it comes to the frequency that they can reach, and there's also the different turbos features that they have. So for example, the Core i9K has this new feature called, it is called, you see, it's that so new. It's called ABT, but it is adaptive boost technology. So adaptive boost technology actually allows you to have all of your 8 cores reach 5.1 gigahertz of frequencies, which is awesome. Imagine all 8 cores out of the box without having to overclock or anything to reach 5.1 gigahertz for all your different applications that you're using for gaming or for content creation. That is pretty cool. So that is a completely new feature for the i9K that we're very happy, and we're kind of excited to see people play with it, to see what they can do with that.
Yeah, so, and it is. I will note just for that, we were really excited to work with Intel like we historically have been, to be able to enable that Intel ABT functionality within the UEFI. It is a special string that essentially has to be incorporated within the UEFI firmware environment so that you can toggle it on. So for many of you, if you're kind of familiar with previous generation kind of Intel architectures, Intel has kind of continued to scale up how they can dynamically increase essentially frequency. And so this started off with Intel Turbo 2.0, and then we had 3.0 boost. And then last generation, you had the introduction of the thermal velocity boost, right, Alex? And
yep,
now we have the Intel ABT. So you literally almost have 4 different levels to really be able to fine tune kind of maximizing the performance. If you make the investment in a good motherboard with a good cooling solution, you can really get some impressive performance with very minimal effort. It's pretty much almost just going into the UEFI, toggling the function, and you're going to be able to get even better performance than the baseline numbers that are kind of being quote unquote communicated. So I think that's pretty amazing that that level of frequency is essentially ascertainable with just going in, toggling a function, and jumping into that. And for those of you in the stream, we'll actually have a little bit of a demo later that will show you how simple it is to be able to go into the UEFI and take advantage of ABT. And Alex, not to cut off because I know that
no, go for it, man. This is a conversation between you and I, so it's all good.
But to clarify, right, the ABT functionality is limited to the Core i9 SKU, correct?
Yeah, that is correct. It's only for the i9 SKU. And you were also mentioning like good thermals and also good power delivery from the motherboard like you guys have. So that also helps a lot, right?
Yeah. And then I think beyond that, for the rest of the boosting technology, the Intel, the VBT, that's also limited i9. And then you have the traditional Turbo Boost 2.0 and Turbo Boost 3.0 will be applicable to all the essentially K SKUs, right?
There's a lot of turbos, yes. Yeah, so I guess to go quickly over the turbos, right? So the first we had turbo, first of all you had the frequency, right? The regular frequency the processor is at. So for example, 4.7, and then you have turbo boost, which what it is the processor will go to a higher frequency, and what it will do is it will look at the temperature and the power, provide that temperature and power that the processor has, and it will decide for how long it will be able to sustain it at turbo boost, and that the turbo boost frequency, so which is higher, and that's for all the cores. And then you have turbo boost 3.0, which is going to be even higher than you have turbo boost 2.0, which is 4 cores at a higher frequency than turbo boost. And then you have Turbo Boost 3.0, which is just 2 cores higher. And then you have Turbo Velocity Boost, which actually is 1 core. Actually, no, there's 2 cores, even going at a higher the highest frequency you can reach. So those were what we had in Comet Lake. So the previous generation, the 10th gen Intel Core processors. That was one in the 10th gen. And for the 11th gen, now we included this new one, which actually allows all 8 cores to hit the turbo frequency of just a regular turbo boost. For the 5.1 gigahertz. So that will be your turbo 3.0. So for example, for the i9K on the 11th gen, you'll be able to hit 5.1 gigahertz all cores, which is pretty cool. Not having, like JJ was saying, well, you just have to go to the BIOS and enable it, but that's the only thing you need to do. You don't have to play with the voltage. You don't have to play with what they call PL1 or PL2 or the TAOs or any other stuff in there. You just go in there, click it on, and it will work. And it's not considered overclocking, and it should be, and you don't need anything crazier than you usually use for a heatsink or a thermal solution. So all those are going to be there. So that's a new feature that is there. That's pretty cool because you're getting the most out of it out of the box. Out of that processor.
And that seems to be one of the primary differentiators that Intel's focusing on. I mean, I know we've been kind of playing with a certain type of fabrication process from Intel for a little while now, and so I feel like part of the messaging gets hung up on core count, and now it seems with a brand new architecture, we're changing up what it is that we're looking at for, especially for the high-end desktop scene, in trying to quantify performance improvements generation over generation.
Right. Actually, that's a great point. Yeah, because what we're looking for here is a balance between cores, threads, and frequency, right? Because we have seen that frequency actually scales across all applications, right? Regardless of the application. Because if you have an application that it just uses one thread, then if you increase the frequency, then it will scale with that. And we're in a point right now in time that not all applications scales with cores, right? Not all applications will take care of advantage of all the cores. So that's where we're trying to find that fine balance in the 11th generation of that core frequency balance. Sorry for the redundancy, but that's what we're trying to shoot for here.
No, I think it's important because we've gotten a little comfortable, I feel, with like, a certain number of cores at a certain number of tier means a certain price tier.
Exactly.
And this conversation changes over time as we start refining a certain type of manufacturing process and we start moving through different products and solutions for different tiers of potential consumers out there.
Yeah, and I think it's also important too that when we holistically kind of take a look at an architecture and a CPU, right, that there's a lot of different aspects inside of the CPU that influence relative kind of application performance. And Intel kind of really started this a long time ago with incorporating more advanced instruction sets, right? And these instruction sets were kind of selectively utilized, not within every application, but as different applications incorporated them in, you saw selective improvements in those applications because of those instruction sets. And even within this generation, I'm sure Alex can speak to that, there's been some new instruction sets that have been incorporation. There's actually some kind of next generation stuff in terms of kind of neural-based kind of co-processing that's now based inside the CPU, where you might start to see applications and maybe in the professional spaces and editing application suites that similar to kind of how the GPU can offer acceleration or decode pipelines, then now the actual CPU isn't just going to be used from a traditional processing sequence fashion. It actually can leverage these more specialized, essentially, functions that are built into the CPU. And even in the GPU, the XIII graphics, the pipeline is really robust, right? I think it offers 10-bit based support. You have high-level decoding and encoding-based pipeline. So take, for instance, like in a professional, editing suite, you could actually have the decoding be handled by the GPU, and then even if you had a discrete high-end like 30 series GPU card, you could then still actually have the encode handled by that, and then still all kind of be processed through the CPU. So it's really interesting that literally you could be leveraging your CPU, your iGPU, and a discrete GPU all in the same platform. And these type of things are a little bit tricky sometimes to kind of always get a clear understanding of from generalized reviews, because when you kind of have to jump into understanding what is going on, you might only be looking at it from just one scenario, and this doesn't necessarily present the entirety of how the product may or may not be used. So it is important to try to get a little bit of a good understanding at, what is your target use case scenario? Are you gaming? Are you streaming? Are you going to be doing a little bit of content creation? Are you doing, productivity, science and simulation? And then from there, try to see where the feature set and the functionality aligns in. And I know that, JC, you're going to probably ask Alex about some of the transition items from Z490 to Z590 on the chipset side. But I think that's also part of the narrative of going into 11th gen and Z590 is that you take a look at the platform and you're also talking about things like storage with NVMe, PCI Gen 4, USB 3.2 Gen 2, Thunderbolt 4 support, of course, next generation specifications for networking like 2.5 gig and Wi-Fi 6 or Wi-Fi 6E, and those kind of things. We want to separate them, but they kind of all come along for the party, right? It's all part of the platform experience.
Yeah. Which is great, and also it kind of brings a point with taking into account all those new I/O improvements when you're talking about the USB 3.2, 2x2, and all those different. Oh, it's probably easier calling it like USB 3.2, 20 gig, 10 gig.
Yeah, 20 gigabits.
Yeah. I kind of gave up on all the Gen 2.
Me too.
Gen 2.2. Yeah.
Me too. Is like, that naming scheme sounds
not great. It's not great.
It could be an user improvement, but then again, who am I to talk? But, anyways, So one of the things that is pretty important with all those different peripherals and IOs out of the chipset is that we also have, because we are aware of all the increased bandwidth and all that, we have increased our connection between our chipset and our processor, so what we call our DMI. We have increased the bandwidth on that side of on that guy. So that is to make sure that we're not bottlenecking. That the processor does not bottleneck and the PCH does not bottleneck. All the information is coming in from the PCH all the way to the CPU, so you can have a faster calculation, and also attending all the different instructions and commands that are coming in from there. So with all those different things, it's pretty neat, from Wi-Fi 6 and 6E, and also the one that I'm pretty interested. Well, Wi-Fi is definitely very interested, as you'll think that a desktop doesn't use it, but actually the desktop I'm talking to you from right now actually has a Wi-Fi 6 right now. That's how I'm actually connecting to you guys. So it comes in really useful. I didn't want to throw an Ethernet cable from the office all the way to here. because then I will be sleeping with the dog.
I feel attacked because I'm running off of a new Switch right now.
Well, I think
No, I am
cool
jealous
part-
that you can retro a Switch. I would really like to do that, but that will be my vacation project.
Right. Just like let me punch some holes in some walls so no one notices.
Exactly.
I think that's the cool thing, though, ultimately, right? Was that when we look at the platform like what we have with Z590, is that you get that flexibility that really, if you want next generation hardline connectivity, it's there, right? With 2.5 gigabits, which is afforded by the Intel-based controller, as well as if you want the next generation in wireless connectivity and even Bluetooth, that chipset that you guys have with the AX-based chipset, the 200 series, gives you either Wi-Fi 6 or Wi-Fi 6E. And of course, we've got routers to be able to enable both of those experiences. And one thing that a lot of people forget is that the numbers kind of get thrown out there a lot in terms of the overall throughput. But if we break it down into even nominal real world throughput, if you were to have a good quality Wi-Fi 6 router, you were to take one of these motherboards and pair it with a router, you can legitimately be seeing 500 to 1,000 megabits in terms of your throughput. You're talking about 5 times the speed of a 10100 Ethernet cable to literally the speed of a gigabit Ethernet connection. And with, in some scenarios with Wi-Fi 6, and even then, as you definitely move into Wi-Fi 6E, you can actually exceed 1 gigabits in terms of wireless throughput. So that's pretty crazy that you're talking about a speed that is literally faster than a gigabit-based connection.
Well, and JJ, from our last stream, because I was talking about how we were trying to do that locally. Now I am on 2.5 gig and higher for all of my cabled connections, and we just put in a Wi-Fi 6 router, and it's overkill, and it's such sweet, delicious overkill.
But that's the great thing, right? Is that you have that flexibility to be able to, scale, right? Is that more bandwidth is always going to be a benefit. So, as you continue to use it, whatever you're going to be doing with it, it's nice to know that you have that pipeline. So, and that's the other, last point here, I think is an important thing to keep in mind, that from this upgrade narrative from not only the 11th gen CPU side, but on the CPU side, if you're coming over from an older platform, which many of you probably are, maybe have a build from 2 years ago, 3 years ago, 4 years ago, 5 years ago, there could be a huge number of kind of concurrent spec upgrades that you're talking about, right? Maybe your motherboard didn't even have USB Type-C header. Maybe it doesn't have RGB headers. Maybe it doesn't have even Wi-Fi. It doesn't have Bluetooth. Maybe it only has one M.2 slot, and that's not even a NVMe M.2 slot. Maybe it's only limited to SATA. So it's always important too that sometimes the reviews are directly kind of comparing something from one immediate prior generation, and that is definitely a valid point. But the vast majority of users, when they're either upgrading or they're building a system, right, they're not usually going from one immediate chipset and going over to the next. There is definitely enthusiasts that we have that do that. They want to be on the bleeding edge. But for the vast majority of users, you're probably looking at a 3 to 5 year cycle. So when you do that, there's probably going to be a lot of things that are baked in there in terms of the upgrade narrative.
Yeah, and just remember, RGB gives you more frames per second. The more
and we got a lot of
RGB you have,
it's like
the better your gameplay. It's directly correlated.
It's 2 frames for every RGB. Right?
Exactly.
That's how you do that.
And if it's in rainbow mode, that's off the charts.
You got Rainbow Bridge, and you're just off and running. Alex, just as we're kind of wrapping up this conversation, and pardon me,
I enabled some RGB.
Did all the RGBs. I love it. And pardon me taking a step back here, but one of the things that I do kind of want to drill down on just one step further, and this might be a little rudimentary for some of the folks that we've got watching on the stream, because they're definitely on it for some of these high-level tech conversations. But what is Intel looking at in terms of these different parts and processors offerings? Is there sort of a general guide, or is there a general flow to Intel's offerings this year for maybe a box that's built more for specifically just gaming, for multitasking, content creators? It seems like this layout from Core i5 to Core i9 is a little more streamlined and a little bit more focused.
Yep.
So it would seem to me that there's got to be some sort of Intel aesthetic for who they're targeting with some of these different parts.
No, I completely agree. So what I will suggest and recommend is, for example, we'll start from the bottom to the top. So the i5K, I think it's one of my favorite, because I think it's a great option for gaming. Not only because it provides all these different features and performance into it, but it's also price performance. it's a great. I think, well, you guys can have a better quote on how much it is, but I think the pricing where it is and the performance it brings, I think is great. Paired with one of JJ's great motherboards from the Z's, so you can overclock it. If you can overclock it, actually it performs even better. You can guys go check, for you guys who are in the chat and watching us, go check some of the third-party reviewers and see what the performance is on that. I think is amazing. For the i7, as we start going up the stack, so we have a little bit more, and we're going to have more cores, right? So we're going to increase the core count by 2, and then as we go to the Core i9, we still have the same core count and threads, but the frequency increases. So for those two, I mean, of course, gaming is always there for both of them, but as we go with the core increase and you get the threads and you get more frequency, definitely content creation comes in there, and especially with the increase on the clocks per cycle, that definitely helps a lot when it comes to workloads on that side of the content creation.
Because I also think it's kind of, sorry, just to jump in on that point right there, because I always think it's kind of interesting, especially as I'm going through reviews.
Right.
I personally fall into that trap of overbuying for some of what I actually need to get done when I'm looking at something specific. And there's always that kind of like that FOMO, like I might be focusing on a box that's almost exclusively going to be for gaming, but what if I want to stream and edit video and multitask all at the same time? And then that never really happens.
Yeah, exactly. Yeah, it's like I want to do everything at the same time, and then video compress and render and game, and live stream.
And then also video call with my parents.
Exactly. While I listen to a podcast.
Exactly. All from this one box. I couldn't possibly use anything else to offload some of these other activities.
So I agree. So like, that's what we're saying. Like, if you want to do everything and more, you want everything in the kitchen sink, definitely the Core i9 will be the one looking for. If you're looking for a great system to game, that you can actually have a great performance, a great price value, all the stuff, the Core i5, I think is the way to go. I'll probably throw it over to JJ to see like which motherboard he thinks we should pair that up with, because I think it will be a great pairing right there. This is like, dinner and wine. The dinner.
I was going to say, like, what kind of beer and pizza are we pairing?
There we go.
It's probably could go a little classier than that. Let's shift that up. And again, JJ, you've definitely been contributing a lot for some of these individual points. But before we move over to those motherboards, Alex was talking about like pricing and parts and components. And I just like to remind folks, if you do want more information, we do have links on what's available, the pricing, what you might want to be shopping, or just to get a little bit more information on your screen while we're all talking about this, you can catch that info right now. So that covers sort of the basics of Intel's new processor lineup. JJ, what should people know about the new Z590 motherboard lineup from ASUS? We got to dig in.
So we're going to dive into, I think, quite a bit, but I think on, the highest level, right, the big focus for us with this generation was really just try to take the great foundation that we had for the Z490 series and make them even better. And that really kind of falls into a couple of kind of key areas. So one was going to be kind of a real top to bottom focus on even giving you a higher level of power delivery. So pretty much everything from like our Prime series, a Dash P model, all the way up to TUF Gaming ROG Strix, to the ROG models, are all going to be using very high quality power stage based design implementations. And that's, when we're talking about that, we're actually talking about the VRM. So as an example, if I go ahead and just pull over a board here, right, this right here, this is our Maximus 13 Hero, right? And so this is the section that I'm talking about, right, is going to be the power regulation section. And a lot of times there's a lot of there's a lot of discussion regarding, the overall kind of experience and the
that
requirements.
That was very diplomatically put.
There's a lot of discussion that's out there in terms of kind of, the relative power delivery experience. But it is important to remember that when you talk about power delivery on a motherboard, especially from our perspective, we're the kind of real world record holder in terms of kind of not only overclocking records, but in terms of also having, I think, an enthusiast series of boards, especially with ROG, that has really kind of been a benchmark generation after generation. And it's not just the power components. You can have the best power components on the market, but if you had a poorly tuned UBFI environment, it wouldn't matter. I try to usually communicate this from the perspective, if you were to put the best engine in the world, it had 1,000 horsepower, V12, whatever it might be, whatever the engine. Maybe it's even a hybrid, right? It's got, electric and it's, a combustion, but you had a horrible kind of, transmission system, you had bad tires, you didn't have good body to weight ratio. It wouldn't matter. The car wouldn't handle well. And very similar that on a motherboard, when you talk about the overall experience, when it comes to really maximizing the CPU, the platform, the overclocking capability, it's not only the power delivery components, it's the thermal design, it's the PCB and the topology, it's the UEFI tuning. All of those pieces kind of have to be in place to really be able to create a great experience. And definitely we did that for Z590, and I'm going to show you some really cool stuff that we did on the hardware side. We also took a look at evolving a lot of our AI-based technologies. These are kind of branded terms that we have for things like our AI overclocking feature, which we're going to do a demo of, which really helps us streamline and offer really easy and accessible experience for high-level overclocking. AI cooling, which is an evolution of our fan kind of tuning and control and calibration options, which can be done in the UEFI environment, in the BIOS, or in the operating system for advanced fan controls. We've also got a really cool demo that we're going to do with something that we call the HydroNode header, which is a brand new innovation that allows us to control multiple fans from a single header. Where in the past, if you connected multiple fans to one header, they would all be using the same PWM output control signal. So that's another kind of cool implementation. Networking and our AI networking, where we have advanced packet priority control software. We talked a bit about earlier about like 2.5 gigabit networking, Wi-Fi 6. We've got a really rich set of software that allows you to have a lot of flexibility at, tuning and prioritizing your network-centric services. So that could be a game, that could be, you uploading something online, or it could be streaming, video on demand, whatever it might be. And then I think from there, other going to be kind of quality of experience elements. These could be things that even making things like your M.2 installation simpler and easier, having an integrated I/O shield, to higher quality audio that now for many of our boards this generation, we've got a brand new ALC high quality audio codec. So, I think like always, what we try to do is we try to look at what's the experience that a user wants to have, what's the budget that they want to spend on their board. We don't use the word budget. Sometimes people refer to that as just like entry level. Our perspective is you might have a $250 budget, or you might have a $1,000 budget for your motherboard. And our goal is to try to say that whatever that respective budget is, along with your series focus, as well as your focus that you have for your build, we want to try to give you the best board possible. And so we've got multiple series, and we'll be going through those. We got the Prime series, we got the TUF Gaming series, ROG Strix series, and then our highest end ROG Maximus series. So that's kind of a general, I think, recap of some of the stuff that's new for Z590, but we've got a lot of stuff to kind of get a little bit closer into.
Yeah. I'm going to try not to hijack the stream on just all of the audio tech, because, I can nerd out with you on like the codecs. And I do want to kind of pick your brain on what this new the AI, the noise reduction is.
The GNA noise reduction.
Yeah, so that was something that we introduced previously, our AI noise canceling technology. That's part of kind of our total experience when it comes to the audio implementation. So when we first launched it, it was one way, so essentially single directional. That means that if you connected any microphone, it can be a USB mic or an analog mic, we would use our advanced machine learning model to essentially help to filter out things like, if you've got a nice keyboard, you got making mechanical keys, you can help to go ahead and filter those things out. And now new for Z590, we have a bidirectional based AI noise canceling implementation. So this actually allows you to go ahead and apply it to your incoming audio. So if you're joining a friend on in a game stream, or something along those lines, if you're on Discord, TeamSpeak, Ventrilo, whatever you might be using, it doesn't matter. You can apply it to incoming audio, and then it can also be applied to your audio. So that's a really cool implementation. And we've actually done a lot of testing too that even compares to some great software like NVIDIA, where they've got RTX Voice, which is a fantastic option. Even compared to there, we noticed that we have a little bit of a lower penalty in terms of actually frame rate performance. So we definitely advocate, try it out. You might be really impressed by the actual usability and functionality of it. And it's accessible just very easily within our Armory Crate software.
Yeah, I've been really impressed. Again, coming from an old school recording background, it's still a little bit magic to me that we're hitting such low latencies with real time audio manipulation and noise reduction in these setups. But it's definitely been a feature I think we've been keeping our eye on, just the times that we're living in right now, where even so deep into shelter in place orders, I have so many friends and family that do not consider the audio they are trying to send to my ears. And it's like I've got to do everything on my side to try and fix it up for them.
Well, yeah, you don't consider it until you have doing. I don't know. I guess before we were all on Zoom, nobody really paid attention to that. But now that we're all on Zoom and video conferencing, it's like, oh, what's going on in the background, or
Well, and
why
it's
are you
funny
hissing?
because and you get that feedback from someone
Exactly.
else because you're not hearing yourself. So people are like, "Oh, this is what I've always just jumped into conference calls." And you're like,
Well,
"Oh, well, apparently you've always sounded like garbage."
well, that's why you and I have like the headphones in, or at least that's what I do. Is like so I can hear how do I sound through the microphone, so we
Right.
can have a yeah, yeah, yeah.
It's strange time. So like I said, so I'm not gonna hijack the whole stream just
On
talking
audio.
about audio because
No, no
I
worries.
could do that. But no, we should really jump into checking out these individual product lines because I feel like especially from some of where we kind of ended the Intel side of this conversation, talking about those individual processors and those individual parts, holistically. And it's why I love doing streams with you, JJ, is we do want to talk about sort of the expectations for what that total package should resemble. So where do you want to start? I mean, we started Core i5 and went up to Core i9 with the
Yeah.
processors. Do you want to
I think let's
start
go ahead.
high
We'll
low
start
or
with kind of I think our foundational series, which is really kind of a benchmark for ASUS, which is going to be the Prime series, the classic kind of white boards right here. So our focus model that we're going to be touching on here is going to be the Prime Z590-A. But I think another model, if somebody is looking even for a little bit lower price point, but still a really great board, is also going to be the Z590-P. And we also do have a micro ATX version as well for somebody that wants to go with a little bit of a smaller form factor board. So one thing I will say though is that we're going to kind of go from, I'd say, more cost accessible, and we'll go up to our kind of our flagship series boards as we tour these boards. But I do want to make it very clear that even on something like the Dash A, I have 100% confidence the 14-stage power delivery that we have here in terms of our team power stage design, which team power stage just means that essentially the power stages that we have, we combine them together. They're essentially combined together to be able to offer very, very fast current delivery performance. And that's important because since we've got high frequencies and we have a high number of cores, we want the actual power delivery solution to be able to dynamically kind of go down and ramp up, and that's kind of key. And even if you were to go from an i5, i7, i9, you can run an i9 on this board, no issues. So don't feel that you have to kind of jump all the way up to, the Maximus 13 Hero or the Apex or the Extreme or the Glacial board to be able to run that. We generally find, though, that as users do, of course, buy a higher end CPU, they're going to go to a higher end board. But let's take a little bit of a closer look here at this board. You can see it's got a really nice, clean, white design aesthetic. So this is a little bit different than I'd say the traditional aesthetic that we have for our gaming lineup. This is a little bit focused more towards kind of prosumers, professionals, but at the same time, definitely makes a great board for those that are interested in streaming. I'm going to go ahead and, though, show you something that's going to be pretty cool. I'm going to cut to a secondary shot here. Let me set this up on a secondary camera
fancy
shot.
with your 2 camera here. I love it, JJ.
And you guys can see something pretty cool here. So give me a second.
I was feeling all good just having like a nice shallow depth of field for my A cam, but
Yeah,
you've got
but now
overhead
he
going.
step it up to 2 cameras.
So here you can see one of the first things that we have on the board is going to be, this is the large heatsink assembly, right? You can see these are very large heat sinks that we've got on the board. And you've got, of course, nice shroud that's there, nice little accenting. And of course, this does have an integrated I/O shield that's on the back of the board there, so you don't have to worry about mounting that. You have these what are called ProCool power connectors. This is going to be present pretty much on all our boards. These are actually thickened pins, so they carry a higher level of current compared to a traditional design. So, by default, the actual CPUs, they're actually pretty impressive in terms of their thermal performance and the overall power consumption. But if you enable things like Intel ABT, or you definitely go about overclocking, you can easily be adding, 50, 75, 100 watts of additional power consumption. So having, a design like this just helps to give us an overall better experience. Now, one of the other cool things that I'm going to show you here is that a lot of the boards, what we've done is respec the layout to where you can see we've got 1, 2, and 3. So pretty much on all the boards, moving on all the way up the stack, you're going to have at least 3 M.2 slots, and you're going to go up to boards that have 5 M.2. So that's kind of the transition focus, especially on Z590, is to give you a lot of M.2 connectivity. One really cool thing that we did also in a prior generation that we incorporated here is, you'll see right here, these are the screws for the M.2 heatsink. You can see right there, that's the heatsink, right? There's the thermal pad. but the screws are actually captive. So that's cool because it means that you can't lose the screws. They're stuck on there. So makes it really simple, really easy, and you can use a traditional Phillips or flathead for this. But one of the really cool innovations...
You definitely saw part of my last PC build then. That's incredible.
Chasing the screw under the table.
That was the subtext, the subtitle of my PC build is chasing the screws. So the taming of the screws.
One of the cool things that you'll see right here is here's an M.2 slot. And traditionally, many of you know the pain that what you're going to have is you're going to have a nice precision tip screwdriver, ideally with a magnetized tip, and then you have to have, of course, that steady hand to not drop it, right? Well, we took care of all of that. New for many of our boards, we have something that we call our M.2 Q-latch design. So if I take the drive right there, you'll see right there that there's now this latch mechanism, and I just have to line it, and then I can lock it into place, and that's it. There's no screws.
What? Sorry, my mind just exploded.
If you notice there, I try to lift the drive. The drive doesn't come out because it's now been locked into place. And from there, you just have to mount your M.2 heatsink, and that's it. But no little screw to drop in, shake around in the chassis, potentially lose. It's now just integrated. And if I need to remove it, then from there, lift it, pull it out, and I'm good to go. So ASUS, you know, we've had a long track record of innovation on little things like this, from integrating the I/O shield to integrating things like this Q-latch design, to even things like the enlarged, what we call Q slot, which was graphics cards. Some people might remember that this used to be very thin. We were the first manufacturer to design a wide-bodied switch, so they made it easier to eject. Or things like where we have a single-sided latch design for DRAM. So that means at the top, I just have to pull one out and I can pull my DIMM out. I don't actually have to do it to both sides. And that's very useful when you have a large graphics card installed on the motherboard. So that is a pretty cool little innovation.
Especially for my pump and cooler, like right now on my current setup, if I got to get in there if I want to install more RAM, I've got to gut my radiator to get it out of the way, because I did not plan very well on this PC build. I just need to highlight something really quick here, because you showed that latch design for the M.2. And I love that you just practically showed it, because I would have been so tempted to do the, infomercial hand acting. Has this ever happened to you? I'm mad I didn't think of that first. I don't make motherboards, and I'm still angry that I didn't think of a quick latch system for an M.2 drive before now.
That is awesome. I mean, even like when he was saying like, oh, we were the guys who pioneered adding the I/O shield to the motherboard right away. I was like, you know how many times I put in the motherboard and then I forgot to put the I/O shield, and I was like, I'm almost done with the build, and stand it up and look, I'm like,
nope.
Oh, crap.
Yep. Yeah, it makes the process easier. And some people also, if you're not aware, the actual integrated I/O shield also does enhanced EMI and ESD protection. So it's not just the ease of convenience, it actually helps to give you a better quality build as well. And kind of moving on just from a kind of little visual tour here on the board, we talked about the isolated audio design. So of course you can see that little bit of that yellow trace that's on the board there. We have the shielded audio codec, our audio grade capacitors right there. So this board also gets you covered there. You also are going to have, of course, USB Type-C internal connector that's on this board. So you can make sure that the latest generation chassis, you have your USB 3.Gen 2 available to you. Let me see if I can also show it to you here, but there's a header. Yep, I'm going to have to pull it in there, right there. That is our Thunderbolt header. So this will actually allow you to connect our Thunderbolt 4 add-in card. So while this motherboard doesn't come with Thunderbolt 4 built on board, you can go ahead and purchase our Thunderbolt 4 add-in card, drop that into a slot, connect that to that corresponding header, and now you have access to Thunderbolt 4. So that is a great, I guess, additional level of flexibility that we're affording to you, right? And I think last but not least, we switch over here. You got some nice little standard stuff that you can expect, such as like our debug QLED. So you can see one for the boot device, the graphics card, the DRAM, and the CPU, along, of course, with things like your ARGB headers, which for this generation, we have also gone ahead and added more headers. So all the boards at a baseline have at least 4 headers, and our Premier boards have 3 ARGB headers as opposed to 2 ARGB headers in the past. So that even gives you more flexibility. And you can also see here at the top, you've got kind of all the key headers that you need, right? CPU fan, CPU optional, so that's great for kind of your traditional tower heatsink or 240, 280 millimeter base radiators, and then your AIO pump header as well. So really, it kind of gets you to everything you want. And I think from what we were going at again is that this is kind of one of our entry-level series boards, and I think that right off the bat you can already see that you get a lot in this board, right? With very little compromise here, and it's only going to keep getting better as we move up the stack. So I do want to just see if anybody had any maybe questions in the chat from the Prime series before we go to the TUF gaming model, which we're just going to keep moving things on up.
I mean, we've been getting a live chat just streaming through, and honestly, as many of the questions have been coming in, you're already starting to touch on and address like what some of the chatters already there. So I think we're pretty good to move on. But Mike,
cool.
I did want to check in. Were you in the live chat telling us that we might have a special surprise guest? Is there someone who is waiting in the wings?
Maybe. Let's see.
Is there?
Here we go.
There we go.
Hey, what's up, guys? How you guys doing? Yeah. How you doing? I see somebody who I recognize just from hanging out with him yesterday, just for a little bit on stream. What's up, Alex?
What's up, Roby? How's it going?
How you doing, man?
I'm back from LA, back in my own studio, showing off the awesome PC that we built, and we're giving away, featuring the 11900K. We did this custom design and custom case specifically for the team at Intel to celebrate the launch of Rocket Lake. And so just wanted to basically come on, show it off, and get people stoked for potentially walking away with this beast thanks to people like Intel and ASUS, obviously. And some of the motherboards you're talking about, I'm sure the Z590 Gaming E was one of those. And then, of course, we've got the unicorn, the ROG White Strix 3090 sitting in there with all of that beautiful things that people can basically walk away with. I mean, a beast of a machine, obviously, hopefully worthy of the launch that just happened. So
it's definitely worth it, man. That's a beautiful piece of art right there, man.
So it was a lot of fun to basically get built. It was a bit of a. Some work of art and all that sort of stuff, but there's a ton of details on here, things from your guys's, like we got the rocket-esque pattern, which was a very, NASA-esque, obviously all white and black in terms of clean, lots of RGB, which means it's 200,000 times faster because it performs better the more light there is. And so we know that those are pretty much the most incredible parts here. And then, of course, tons of fans and then tons of power, and all powered by the 11900K, which is pretty awesome. So pretty stoked about one lucky person walking away and winning this bad boy.
Yeah, it definitely looks like it's ready to fight some kaiju. I really wanted to know, because I was kind of digging through when you were putting it together. Did anything kind of catch you by surprise? This is a new chipset. This is a new socket. These builds can be very intricate. How did the assembly on this go?
So there was some stuff that obviously caught us by surprise. In fact, I think the biggest thing was just in terms of playing around with some of the new, specifically the M.2 thing that we were talking about. They were showing off that little latch. We were just getting it right for the first time. Like, I was just like, I know this is supposed to be easy. So we struggled a little bit with getting the M.2s in here. In terms of the chipset and stuff, not much. I mean, our full review is out and live, and Alex and I, we talked a little bit about it yesterday. In terms of, that sort of thing, but getting it set up and everything, given that LG 1200, that we've had the socket out for a while, Z590 had been out in the first place. So it wasn't something that was new, right? Like with the launch of the actual CPU. So most of our surprises were actually build related, because we got this ridiculous, I wish I had it. I'd show it off. This ASUS, that beautiful, $1,200 water-cooled motherboard that we ended up having like just a slight technical issue with, and then that kind of changed like what we were going to do initially. But all in all, like I think how the build turned up once it was done ended up being incredible, and it looks really great. So
what was the first thing you fired up on it, if you can remember?
The first thing we fired up was Microsoft Flight Simulator, because again we ran actually quite a few of little benchmarks just to make sure that it was performing very similar to the engineering sample we had gotten sent from Intel earlier. So we took a look at Cyberpunk 2077, of course. We played some Microsoft Flight Sim on it because I like blue. This is very blue. The sky is blue. There was lots of blue there, so we definitely enjoyed that. And then for the most part, we obviously, the other thing too is we played around some 3D Mark and stuff like that as well. So and we wanted to make it was funny. It was nice to have two samples at the time. Like we had the one that was in here, so we got to compare the two, and so it made our review a little bit more interesting. At least that's what we tell Alex, but I don't know. We'll go from there.
But he has to go and read it and find out. Great job, Robbie.
For the next generation launch, Robbie's going to be like, can we get 3? Because that'll make the review even more interesting.
Oh, yeah. I have Alex's contact information now. I'm pretty sure he's ready for my spout of emails when it comes up to, hey,
I'm actually surprised
I heard about some new stuff.
He hasn't hit me out yet for the Core i5 yet.
No, I have one of those. I got my press kit right here. Everything's ready. We're good to go. We're okay.
Oh,
we're
you're saying okay. That's good.
Yeah, there's some other things we won't chat about yet on here, but I'm sure I'm gonna want some samples for some of those things coming up.
I can, yeah. Hit me up.
Well, that is
anyway, guys. But yeah, no, came out great. Excited about it, and excited for people to basically get a chance to win.
Yeah.
Awesome build, man.
Thank you very much, guys.
Monster looking build. That thing is
sounds like you guys are going to go back to talking about pretty awesome motherboards. Give me 1 second because I want to show. I think this is for ASUS. I'm going to show this thing off. You guys got to see this. 1 second.
Yeah, and I think actually, Robbie, I think guys in the chat, we do have some images if you guys want to see. So one of the things that actually we're really excited about with this formal kind of launch for the 11th gen series processors is that we do have 3 boards that we're announcing that weren't initially available when we first launched our Z590 lineup. So we have now the Maximus 13 Apex, the Maximus 13 Extreme, and also the Maximus 13 Extreme Glacial. And actually the demo that we're going to be doing here for the AIOC and the DRAM overclocking with 5.3 gigahertz DDR4 memory from this awesome Kingston HyperX kit is going to be actually on the Extreme board. But I think we might be able to actually show some images for you guys so you guys can actually check out the Apex, the Extreme, and the Glacial. But those are our 3 latest boards. And we also, a little bit ago, did launch the Z590-I, which is our mini ITX-based board. So yeah, here you can see the beautiful Apex board, which has got a very different stylized aesthetic. It's got 2 DIMM slots because, of course, it's really focused at overclocking and our DIMM.2 based design. I think Robbie right there, yeah, he's got what I call the pinnacle of all boards. It's featuring a custom collaboration project that we worked with EK on. It's an amazing, it's not a monoblock, it is an ultra block.
This thing is ridiculous.
Yeah, it weighs over 10 pounds.
It's so heavy.
Yeah.
Yeah, we've been deadlifting it. We haven't. I promise. Actually, JJ, don't worry. We haven't been deadlifting it, but this thing's nuts. We're going to be putting it in a different build, but this thing is ridiculous. And so, yeah, I absolutely love this motherboard and can't wait to actually use it with a really ridiculous custom water-cooled build we're going to be doing later on.
Yeah, and the cool thing is on that board, it uses our another innovation that we had, which was called our water block sensor. So the water block sensor interfaces with that large Uber block, and that actually monitors everything from your flow to your actual inlet and outlet temperatures. It's all fully integrated along with RGB lighting. So there's no cabling, there's nothing. It's just you mount that block directly onto the board, and it's a fully self-contained experience that is really streamlined, and it looks amazing. And that cools everything from your M.2 to the CPU to the actual 10 gigabit network controller. It's all handled under that ultra block. So it's a pretty amazing solution.
And the block goes like all the way down. It was like when we finally took it off and started installing everything, we were super impressed at how much coverage you get with this block, right? So, and on top of that, weighs 10 pounds. So already heavy builds weigh twice as much, which I think there's probably a new benchmark that the heavier the PC is, just like the more it's lit up, the better it performs. I think that's going to be the other thing too. I think you'll find out.
And this is this is quote unquote the baby brother, but it's really not. It's really our flagship series board, which is the Maximus 13 Extreme. You guys can actually see right here. We've got an image of it. This is essentially the same board, but the non-glacial version. So the glacial version features a full, like I said, EK Uber block that we have on the board, and then this is your traditional, quote unquote traditional board. But really, it's an amazing board. This. Up to 5M.2, it's got 10G, Wi-Fi 6E, absolutely just monster VRM power delivery design, our DIMM.2 add-in card, Thunderbolt 4 built on board. I mean, really, every single thing you could really ask for on a board is going to be present here. And I think somebody actually in the chat was asking about the Dash I board. think we can probably try to see if we can pull up an image for the Dash I. What I'll do first is we'll dive a little bit more into the TUF gaming board, and then we can show you guys the mini ITX board. But that is a really sweet board. If you guys want to go small form factor, we'll definitely have you covered there in the Dash I. But Robbie, thanks for showing off the Glacial, man. It's a beautiful board. I'm looking forward to that build.
Yeah, I'm excited. I'm excited to actually get it going. I hope you guys enjoy the rest of the stream, and excited for the launch, and excited for many people who are picking up their CPUs today. So it's pretty exciting stuff. And anyway, we're gonna go back and continue other reviews, and we will see you guys on a future stream, I'm sure.
Sweet, man. Take care.
Thanks for stopping by, man. Man, so before we get back into the specifics, like when you start seeing the approach that ASUS is taking to some of those just crazy concepts on not just a water block, but like a massive block, this really reminds me of some of those conversations, JJ, that we had years ago about the work ASUS was doing and kind of changing up what our expectations for a motherboard should be. We expect this to be this like backbone of a computer system, but we do need to start anticipating and building around future challenges, and then trying to anticipate what a user might need years after they purchase the product, and their needs are changing and evolving over that kind of a time frame too.
100%. And while we're talking about Z590 right now and 11th gen, I can tell you that we're only getting started, guys. So as always, you're going to want to keep watching what we're doing. We love working with an amazing partner like Intel, and we've got amazing plans for the future. So with that, I think let's actually show off something that's entirely new, which is our brand new design for TUF Gaming. So Z590 is the first series that we are launching the new kind of revamped ID design for TUF Gaming, which now actually has a new logo. And the prior generation, while we've now had TUF Gaming for a couple of series and a couple of generations, it was still using essentially the old TUF logo, which was from an entirely different series. TUF Gaming and the original TUF series are two entirely different product designs with different type of product focuses, although there were some similarity. And so here now with the kind of the rebranding design, we wanted to evolve and kind of redefine the aesthetic for now the new generation. And TUF Gaming is our entry into the gaming series of products. We're going to be at a lower price point than what you're going to have with something like the ROG Strix series and then the ROG series motherboards, but you're still going to get a gamer-centric board, and it's going to still have a great overall experience. So you can see very, very beefy power delivery solution, really nice, clean, monochromatic, kind of semi-monochromatic kind of color scheme, right, where you got black and kind of gray tones on the board, but goes really clean with your build overall. And before I go ahead and pull it off, one of the things I want to show you that, again, when we talked about kind of an upgrade, and we can cut to the secondary cam here, is I've removed a couple of screws, so it's not only one screw holding it in place. But one of the upgrades that we made was integrating in the entirety of the actual I/O shroud. So that I/O shroud is all aluminum. So this is one full aluminum block, along with this very high quality block that's on the VRM itself. So you've got two large, massive heat sinks that are on here to give you very, very high level of performance. And let me go ahead and switch over here to our secondary cam. But you'll see that one of the cool things is going to be in this this type of setup is that this is a dual contact based design. So what that means is that it's making actually contact with the power stages and also making contact with the inductors. So if we go back to the motherboard, let me bring the motherboard over into frame here. You'll see a little bit more closely kind of what I mean. And this was also on the prime board for reference, if you didn't notice that. But when we take a look there, you can see we've got very, very high quality power delivery. There's your inductors, and there's your power stages. And you can see right here that what I'm saying is that that heatsink is making contact with both portions of the power delivery. And that was another ASUS innovation. Prior to that, most designs really only favored just making contact with just the power stages. So we're offering you both of that. And they're quite large. I mean, you can really see the entirety mass of this thing. It's huge. So thermals is not going to be an issue on this board in any stretch. I know somebody in the chat asked about, does this board have the M.2 Q-latch design? You can also see that that's on there. So you still maintain that. This one doesn't have the shielded codec, but this is an engineering sample. So the final sample will have it. But this has the S1200 audio codec. With the DTS audio suite, still 3 M.2. You still also have your, let me see right here, your Type-C. see if I can get it there. Yeah, your Type-C header is also on this board, and then your debug LED. So pretty much everything that you saw on the Prime. One of the main updates, though, will also be is that this one, as opposed to the Prime, will come integrated with Wi-Fi on board. So you get Wi-Fi 6 on the motherboard, along with, of course, that Bluetooth. So, and you get the 2.5 gigabit LAN. So that's kind of, I'd say, the main upgrade, right? Is if you're looking for a little bit more of a gamer-centric board, you want the audio suite and the networking software that comes with our gaming series boards on the TUF Gaming lineup, then this is going to be a great foundation for you in that regard. So that is the TUF Gaming series. So I think next one, we want to go to the ROG Strix lineup. And on this one, I want to do a little bit of side-by-side. So let me actually put the heatsink back on the TUF. I know sometimes people wonder, like, how do they differ in terms of the overall design aesthetic? And one of the cool things with the Strix series that we also implemented in prior generations is we implemented the Dash A model. So the Dash A model is this one right here. So in the past, we used to only offer white in our Prime series motherboards, but a lot of kind of our gamers were looking for, hey, we'd love to be able to see an ROG series motherboard in white. So you can see right here, we've got our Z590-A board in white. And then from there, let me actually compare that.
Like somebody in the chat was
move
saying,
our hero board.
White is the new black.
I got my table of holding. This is my table of holding here. But there you guys go. You can see side by side. So this is going to be the Z590-E. This is actually the Z590-E is what Robbie was using in the build. So this is going to be one of our highest end boards. Really, really impressive board in terms of this feature set. And there you can see it compared to the Z590-A. So kind of either or. You can go with a black themed aesthetic, or you can go with a white themed aesthetic. And keep in mind, ASUS, we've got you covered on both the kind of the complementary components as well. We have white Strix Series graphics cards, white Strix Series coolers, and on the same time, we have black Series graphics cards, and we also have black Series coolers, black Series power supplies, white Series power supplies. So you can match it up entirely, you know, based on your preference when it comes to the overall build. Let me move this TUF Gaming board here. Give me 1 second. All right, so here we can see I'm going to do the kind of the Strix boards together, since there's a lot of similarity between the two. So we actually have a few different models. The ones that we're going to just show you here is the Dash A and the Dash E. And maybe I think we can bring up the Dash I photo, so if you guys want to check out the Mini ITX. But the Strix series is kind of really our sweet spot for the enthusiasts. Pairs really well for people that want i5, i7, or even i9. Kind of hits that sweet spot that it's a good board for really any CPU in the stack. The Dash A is kind of the entry model. We then have the Dash F, which sits right below the Dash E, and then the Dash I, which is the Mini ITX-based board. So same thing, very large heatsink assembly, like we talked about, very high performance VRM with all those power stages. And of course, the connectivity is pretty much going to be the same on point. But there are going to be a couple of little differences. So the first one is going to be, I'm going to show you something on M.2. And I'm going to use my drive for reference here. So this is an M.2 drive. And if we go a little bit closer here, we'll use this for reference. But you can see on this drive, there's NAND on both sides. Okay. On many drives, for a long time, there was only NAND on one side. But we're now entering into the era where you've got 2 terabyte, 4 terabyte, even 8 terabyte based drives. So when you have these M.2 based heat sinks, you might think, well, what about the other side? So again, in another kind of ASUS innovation, we actually created a new type of heatsink design for these higher performing drives and these larger capacity drives. So essentially, you now have a dual heatsink based design implementation. So I'm going to show you what that looks like here. Let me just go ahead and remove the heatsink here. So this looks pretty standard. Same thing like normal, right? You got the heatsink, but there's also going to be a heatsink that's underneath.
Nice.
For the drive. Okay. Now this one, just because of the design implementation, doesn't support the Q-latch design, so you don't get the Q-latch that you saw in the previous, and that's just because of the nature of what we had to do to be able to implement the secondary heatsink. So let's go there. So here you guys can see. Yeah. Let's see if I can frame that a little bit better. There you guys go. So you can see right there, it's got, of course, the thermal pad material, right? That's a thermal interface material. If you peel that off, you would have that, but that's essentially where you would put your M.2.
Nice.
So that would make contact with one, and then the heatsink would make contact with the other side. So if you've got, that 2 terabyte, 4 terabyte, 8 terabyte base drive, then you have both of those covered, okay? So that's going to be an upgrade that you're going to see on these drives. The Strix series is also going to see an upgrade in terms of our overall PCB and power topology. So when we talk about things like our trace layout for the memory, we're going to have kind of a little bit more tuning and optimization on our ROG series motherboards, where we have on the Dash E, it features our OptiMem3 technology, which we used to only offer on the Maximus series. And we're going to actually show you a really cool demo of actually the performance of that. But before I get into that, the one big upgrade that I also want to talk about is going to be here in the Supreme Effects audio codec. So you're going to definitely appreciate this. The S21220 audio codec that we've had for a couple of generations on these motherboards hasn't really seen a big update. But we're really excited to be able to, of course, co-work and be able to now implement a new codec for multiple of the boards for this generation. So there's an ALC 4000 series codec, and the ALC 4000 series codec is going to offer a higher level of performance. The 4080 codec as it is, you're going to get better THD, better to signal noise ratio, and ultimately just a higher quality audio codec. So if you're somebody that does appreciate, music, movies, games, you've got a better quality headphone, then you can go ahead and benefit from that. And that's a key difference between the TUF Gaming and the Prime series, which have the older, very good quality S1200 series codecs, either the S1200 or the S12220, where on the ROG Strix, you're going to get that newer ALC 4000 series audio codec. So if you kind of really care about audio, then that's going to be an upgrade portion, okay?
Nice.
Let me switch over here to the Dash E, and we're going to get to our first demo, which is going to be pretty cool. But for this, let me see here. I actually got to swap some stuff around. Give me 1 sec, guys.
So I promise you, sometime soon we'll have you back in the actual studio so that we can run some people in and out to help you move some things around.
No worries, no worries. So one of the really cool things that we got right here is we have actually partnered with a couple of different partners for this brand new feature that we've implemented. So what I'm going to show you here is actually, these are from Silverstone. These are the first fans, along with there's another partner that we have that also will be releasing it at Phoenix. But these will support our new Hydra node based headers. Okay, so we got 3 fans right here. These are going to be the Air Penetrator 140i ARGB based fans. So you might say, well, what's kind of special about this, right? What's going on? Traditionally, when you talk about fan headers on a motherboard, we kind of really know everything we would expect, right? Traditional fan header, you can support either a 3-pin fan or 4-pin fan, DC or PWM. And for a long time, ASUS have had great fan controls, right? You could go into the UEFI, or you could go in the operating system, you could click a button and you could calibrate all your fans. You could tell the fans where they're located. You can control the fan curves. But what would happen traditionally is, let's say if you had 3 fans, like I've got right here, and let's say we connected that to 1 fan header. So your chassis fan header on your motherboard, all the fans would be linked together in terms of how they would operate. That's the nature of the PWM output signal. So what that would mean is that essentially if I connected this to 1 single header using something like this here, and we'll go to a closer shot on the B-cam, but this is a splitter, right? Let me go there to the white, right? Where I've got the 3 fans connected to 1 header, which would connect onto the motherboard. All of these 3 would run at the same speed, right? So whatever my fan curve is, or if I set these to like 1200 RPM or 1400 RPM, they're all going to run at 1400 RPM. But now with the Hydra node header, we have a specialized hardware IC. This is not something that can just be done in software. It requires hardware-based design implementation. But when you plug that into the compatible header with the fans, we can now give you full independent control of all of the fans. So each one of the fans will still be individually be able to be controlled. So I'll show you a little demo, and I will actually show you how they look in terms of the header. So let's look at the board first.
You were catching my last PC build where I've got 3 fans right off my power supply that I had to split off of the same header, and they all kind of run the same even though they don't need to.
Yeah. Let me see right here if I can find the header for you guys.
Does it run a little? Hopefully it won't be too loud.
Oh no,
yeah,
no,
the build JC under the same the same header.
No, I mean it's just that it doesn't run, like optimal. You know what I mean? Like you would have. I've got the 3 fans right at the bottom, the sort of protected cover for my power supply, and since they're all on that bottom row, they really shouldn't be pulling intake at the same rate. You know what I mean? It's like the entire bottom position. So it's one of the sticky spots on my build where it's like it's fine. But it's not really how that's supposed to work.
So you can see right here, this is your traditional fan pin, your 4-pin fan header. So like, see it says chassis fan 3 and chassis fan 2, right? That's what it would traditionally look like. But when we go to a board that will have support for Hydra node, we'll go to an example here as our hero board where we have the Hydra node header. There's going to be a little P designation. And hopefully you guys will be able to see this P designation when I show you the header. So if you noticed right there, it actually says fan 2P. Might be a little tight right there. Might not be able to 100% see it. But essentially, if it's got P next to it, that P would denote that it's a Hydra node fan header. So let's go ahead and show you actually what that will look like. So I am going to go ahead and connect these fans, and we're going to jump into our OS and show you what this looks like. So all I need to do this is, again, just connect it to the fan header. I'm going to use my XIII for reference and nothing else is special here. There's going to be a ARGB splitter, which will go to one of our AGB headers, and that's pretty much going to be it. So while I do that, Alex, actually, maybe what you want to talk about a little bit while I get this connected here, giving a little bit of insight into the Gear 1 and Gear 2, because after this, I think one of the cool things before we get into the RG board, because that board is going to be one of our showcase models to do our DDR3 demonstration, is talk a little bit maybe about the DRAM scaling that I think the memory controller on Rocket League is really impressive, right? We're seeing that you can hit much, much higher DRAM frequencies. Yeah. So why don't you give us a little bit of insight into kind of Gear 1 to Gear 2, so that while I prep this Hydra node, we can then get into the DRAM overclocking.
Yeah, so JJ beat me to the punch there. I was actually just going to say, Alex, we got to talk about this because I know we're going to be doing a practical demonstration on it.
Yeah, no, more than happy to do so. So actually on Rocket League is the first one that we have done this implementation of Gear 1 and Gear 2. And what we refer to, so Gear 1 is actually using the frequency of 1-to-1 when it comes to the integrated memory controller. So what it means is we're running the controller, let's say at 3200 megahertz. So the memory is also going to be running at that speed. So they're going to be like one on top of each other, right? Now, when we have Gear 2 is we are running actually the memory controller frequency at half of the frequency, but the memory is still going to be running at the frequency before. So even though we're going to have the frequency, we're still being able to keep the other one running at the same frequency, and this allows us to
are we losing Alex here? Hold on, he locked up on us before.
Hopefully Alex will be able to jump back on there in a moment. But I think what Alex was noting, right, was that
what was he about to say?
Yeah, with Gear 2, the really kind of key benefit that you get is that you can essentially be able to drive higher frequencies. And there is a little bit of difference in terms of some people understanding this, that actually as you switch over into the Gear 2, Gear 2 will actually adjust the actual sub-timings and also a little bit of some different string sets in terms of operating parameters defined by the CPU. And this is done to help to maintain overall operational efficiency. But really the key benefit that you're going to get is that you'll have the ability to be able to scale to much higher DRAM dividers. And so it's not a question that you exclusively would always want to run memory only in Gear 1. There actually might be scenarios where you want to be able to run Gear 2 because you'll be able to net much higher bandwidth at those higher frequencies. And you'll also have, like I said, those different set of subtiming values that are present under Gear 2 as opposed to Gear 1. And what this effectively translates into in the real world is about Gear 1, we'll usually see about a limit on the DRAM divider of about 3600 megahertz. This is a little bit affected by single-sided and by density of the DIMM. So whether you're talking about lower density or higher density DIMMs, but as you move over into like 4000, 42, 4400 megahertz, 4,800 megahertz, even 5,000 megahertz, we're going to be showing you a demo with 5.3 gigahertz memory. Then you're going to want to be using the Gear 2 base divider. I think we got Alex back.
Yeah, I'm back.
Yeah, we do have Alex back. So from Intel's perspective here, I mean, this sounds like it's sort of a natural progression from the way that Intel processors can scale. They have a boost clock. Now also kind of contributing that to memory timings. What are some application specific instances where this type of Gear 2 RAM speed might come in handy?
So let's okay, you guys hear me? Just making sure.
Yeah, you're back in. Yeah.
Okay, sorry. I thought they were telling me like, oh, you're muted. Anyways, so yeah, so different. So a couple of different things that we can look at is depending on the application you're looking at. Is, for example, if you're not, for example, for gaming, right? For gaming, we see that there's a direct correlation when it comes to frequency, memory frequency to frames per second. So that will be one place that you can look at in there. But like JJ was mentioning before, you want to make sure you want to test that before, right? Because not all games are developed the same way. So, but we see that in gaming, we see also, for example, for content creation, for video creation, there's a like right there, frequency will help you, especially when you're doing preview. I don't know, for you guys who are doing video editors, preview, depending on the resolution you want to do or you want to watch the preview, can be painful, depending on the amount of memory you have and also the frequency you're running at. So those are things that to keep in mind, that actually this type of new gearing will provide a lot of relief and also better performance in that side.
Yeah, I'm kind of shocked. I built my last system around like trying to edit and cut 4K 60 frames per second video, and now I'm starting to step up into some 8K samples from some of the new cameras that are coming out, and you're like, man, I was humming along just fine at 4K 60. I was kind of dabbling with some of the slow-mo at like 4K 120. 8K is just slowing me way down. It's like I'm gonna have to rebuild just to get this up and running. But JJ, I see some fans spinning around on your desk right now, so I think you probably have something to show us there for these headers.
I'm still running through the fan tuning here, so I'll show you guys in a moment. So I think we got a little bit left.
Oh, okay. I jumped the gun on that one. Sorry.
But I think actually they're ramping down, so it's actually okay. I think I can jump into it here. But I will also actually tack on there to what Alex was noting is that another item that we saw a benefit from the high essentially DRAM frequency is specifically in 1080p ultra high refresh rate gaming. So we actually manufacture, of course, right now the fastest monitor you can get, the ROG Swift 360 hertz monitor, and we actually find that not only is 1080p sensitive to clock frequency, which of course is an advantage of something like what you would have with these 11th series parts being able to run 5.1, 5.3 gigahertz, but also being able to run these aggressive DRAM frequencies, 4400, 46, 4800 megahertz. While this is, of course, definitely extreme and at the enthusiast end of the spectrum, when you're talking about really trying to be able to sustain ultra high refresh rates in these games for the best level of performance, this is an area that you can see a benefit. So if you are somebody that is trying to really push the envelope in terms of frame rate, you can see an actual noticeable impact to the frame rate at that 1080p target with the high DRAM frequency alongside the overclocking improvements.
Yeah, I was definitely a bit skeptical on some of like the super high frequencies, but what kind of changed my mind on that was higher frequency frame rates and then also black frame insertion. So, I know that PCs aren't working as hard when you're doing some of that motion smoothing with black frame, but I mean, 240 frames and also looking at polling and refreshing on monitors is getting kind of incredible.
Yeah, I think we're reaching some the refresh rates up there are getting pretty impressive, and it's definitely making the processor and the GPU work. Getting the run for the money.
So right here, so you can actually see now what's happened is, if you take a look, you can see we have chassis fan 1, we have chassis fan 2, and then we also have now chassis fan 3. So if you notice, as opposed to seeing just one fan, we can actually now see all 3. And if we wanted to go in, you could go in and customize it. So if we wanted one to, let's say, run at a low RPM, 800 RPM, it's hard for you to notice, but I can,
you can definitely
bring up my secondary shot here. if you try to notice a little bit, the fans actually will be running at a little bit of a different value. One's running at a lower speed and the other one's running at a higher speed. And you'll see that a little bit through the oscillation pattern. But if we go through, we can customize that. So you could have one, let's say, running a smart curve or one running a fixed RPM. You can also still maintain the level of functionality that we've had, which you can assign the location of the fan. So you can say, hey, it's in the front or it's in the top. You can even go through and you can name the fan header. So if you wanted to say those are my two front intake fans, then you could do that. So very, very simple, very, very easy for you to go ahead and do that. And again, this is available to you to each one of the fans that are connected. So even though all three of these are connected to one single header,
you can individually customize.
Exactly. You can individually control each one of them. So this is a really cool feature that we have gone ahead and implemented for this generation, is our Hydro node, and we're really excited about offering it. Again, it's not going to be on all the models. On our higher end models, if you see that it lists Hydro node, then you know that it supports this feature. And again, it does require compatible fans, but you'll be seeing more and more partners be able to offer essentially this. And if you don't utilize this, no worries. Of course, we still offer the same classic advanced fan controls that we've had within the operating system or within the UEFI. So if you just still want to have one synced fan profile for all the fans that are connected to a header via splitter, that all still works. And I will also make one note here that you also still do have, let me go here. If I click in, that you do have what's called temperature input mapping. So you can see you've got tons of temperature input sources. What that essentially just means is that you can have the fans respond to a different temperature source. So you can see by default it's the CPU, but maybe you want it to respond to the VRM, or maybe you want it to actually respond to the GPU. In many cases, the actual GPU will be hotter than the CPU. Yeah. So it actually, if you had, let's say, like two front intakes, it would be more sensible for you to run the fans to respond to the GPU's temperature to bring more airflow into the GPU than it would be to responding to the CPU, if that makes sense. And so it's a really cool level of functionality that we have there.
Yeah, I think my triple fan setup right now would crack you up, JJ, because I'm running it off of like a custom thermometer just to get for my intake fans. Like I've got it pointed at a spot of my case that. Again, I'm jury rigging it and it's functional, but it's not ideal.
So I think with that, let's get almost here to the end where we've got just a couple last demos and a little bit here on the motherboard side. But before I go over to the Maximus board, did we have that image of that mini ITX board? I'm not sure if we showed that one, the Dash I board.
Yeah, Mike, did we pull that up?
Should be the Z590
Yeah,
Dash.
I will show it one more time.
Oh, awesome.
Let's do it. Let's make it big. Because it's the mini.
This is the mini.
Oh, yeah. It's such a good looking board. There you go.
No, pull that up, Mike. Yeah.
So there you guys can see it's the Z590 Dash I Gaming. And one of the big upgrades that we made for this generation with this one is that now it integrates Thunderbolt 4 on the motherboard. So you get the Thunderbolt 4, the USB-C 2 header, you get the Wi-Fi 6 on there, the ALC audio codec. You can still run two M.2 base SSDs because it has a stacked base drive. We even made the VRM heatsink solution and the power delivery even more advanced. So literally you could still put in here 100% no issues, a Core i9 in this guy if you wanted to, and have an awesome, true high-performance mini ITX gaming build. So pretty sweet.
Yeah, I've really been digging on some of the work, especially that you've been doing, that ASUS has been doing on small form factor PCs. Like, as much as I love having like, a little streaming stick that can handle my Netflix on my TV, I keep running into these situations where I still need a proper PC behind my TV.
Yeah, I agree with you. That's a really nice. This is a really sexy looking board, man.
That's really clean.
Yeah, it's a fantastic choice. If you're interested in going with mini ITX, definitely a really solid option for you. So I think one of our last items here is going to be going through the Maximus series. And our Maximus series is the benchmark. This is really kind of our enthusiast series of boards. This is for somebody that absolutely wants kind of the flagship. You want the best of the best when it comes to the power delivery, to the cooling design, to the connectivity, to the advanced feature set. This is going to get it to you. So on this board, this heatsink's even bigger. This is all aluminum. It's a double joined actual heatsink, which also features a connected heat pipe. So there's a heat pipe. This is heatsink, 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 and heatsink. It's all It's all heatsink. Really beautiful, clean design. You can see that it looks amazing just in kind of flat. But if you, of course, want to go RGB, you have really, really nice RGB illumination zones. You got the 3 ARGB headers that are on the board. You have the Hydronode headers on here. You have the high-quality audio codec. This one also features an ESS Saber DAC in addition to the ALC 4080 audio codec. So you get double. You get both of those things that are going to be on this board. And this one also comes, I think we showed an image of it, but one of the cool things on the higher end boards and included with the Z590-E is they come with the VGA holder. So if you do get a bigger graphics card and you don't want any type of sag at all, the board will actually include a VGA holder inside of the box. And it's going to tie in here in a moment to one of the really cool demos that we have. But on our ROG Maximus Series boards, you're also going to get a full 1-year licensed version of ADA64 included. So if you want to do your stress testing, your benchmark analysis, it's the industry's best tool. They work closely with us, with Intel, with partners to really be able to ensure outstanding performance analysis that's correctly attuned and supports the microcontrollers, supports the instruction sets, a lot of those things. So we love that we were able to give you that utility. It's included with the board. You'll get it. No cost to you, a full 1-year license. In addition to that, we also partnered with Passmark, and we've integrated memtest built into the UEFI. And I'm going to show you this, where we actually have memory testing now into the UEFI. So when you're first setting up your build, if you just want to check your memory, make sure everything's working right, go into the UEFI, click a button, and it will go straight into a memtest. And speaking of memtest, and when Alex was talking about Gear 1, Gear 2,
trying to talk about it before
let me see if I can pull it out here.
And I love this user. And speaking of memory tests, we're going to show you a memory test.
So this right here, this is a high-speed DDR4 memory kit from Kingston, part of the HyperX series of memory. This is a pretty special kit. We worked very, very closely with their development team on the actual tuning for the board in terms of its topology, our firmware and your UEFI, and Kingston, of course, with their binning for the memory and the actual XMP profiles to be able to offer a truly impressive XMP-enabled experience of 5333. So this is 5.3 gigahertz DIMM. This is really unquestionably never been seen in general enthusiast kind of turnkey experience. Intel's really kind of set the benchmark at high-speed DDR4 for a couple of generations, and we've been at the forefront there. I think in the previous gens, it was really impressive that we were seeing kind of the vast majority of CPUs in the memory controller could do 4,000, 4,200, even in some cases 4,400 megahertz. But for Rocket Lake to be able to, of course, there is some variance between CPUs. Not every single CPU will be able to hit this frequency. But the fact that it is capable with this DIMM to be able to pair it in with a board like our Maximus Hero or like the Extreme that I'm going to show it to you on, that you can literally drop this memory in and run at 5.3 gigahertz. Then imagine enabling our AIOC so that you can be running at 5.1, 5.2, 5.3 gigahertz on your CPU. That's crazy. You could be running 5.3 gigahertz on your CPU and 5.3 gigahertz on your DRAM, right?
That's awesome. That's amazing. Can you just imagine
that's crazy. That's unprecedented that you have this level of flexibility. So I may show you the DIMM here, and we'll go ahead and get it loaded into our system, and it should be pretty quick. Sorry there. There we go. So pretty standard. This DIMM is all about performance, so there's no RGB, but you can see right there, it's a 5,300. Okay, so let's go ahead and pop this guy in, and we're gonna get to it. So give me a sec here, guys. I'm just gonna drop it into my board.
Well, and Alex, I mean, when we're talking about architectural changes, and the fact that we're talking about some very specific and strategic partnerships between motherboard manufacturers, component manufacturers, making sure these components are all making it to people in this enthusiast space. It would seem to me that from Intel's perspective, there could be some concerns on the messaging, making sure that some of this data is getting out. The early review process might rely a little bit more on some of the testing that we took for granted on last generation hardware. When we're looking at something like this, I mean, we're going to see 5.3 gig. That has to be a different kind of conversation. That has to be a different relationship between Intel and the various partners.
It's definitely, we have a very close relationship, especially with ASUS when it comes to developing this. And even last year, ASUS claimed, I think the majority, if not of the world overclocking records that were broken with
For sure.
with the 10 gen. And actually, I don't know if we were talking about this before the stream go live or not, but I was congratulating JJ for hitting 7.3 gigahertz in single
Correct.
core.
Yeah, we did set a
so
world record on our Maximus 13 Apex. 7.3 gigahertz was achieved under liquid helium with our amazing set of overclocking community that we worked with. We actually put out, I believe, a total of 12 world record numbers, including actually breaking our own previous record, which was achieved on an ROG board that held for over 12 years on an Intel CPU. And so it was really impressive to be able to kind of just set some new benchmarks and continue the history of kind of performance that Intel and ASUS have together. So you guys can see here, I'm in the UEFI, our beautiful UEFI. And cool thing for you guys, if you don't know, this UEFI generation, we actually phased it in last gen on even Z490 series, but we went to a high DPI interface, so it's even crispier and sharper and even looks better. But you'll actually see right there at the top, there's an option that says memtest. So I'm going to just show you what that looks like really quick. And then we will actually show you enabling how simple it is to be able to get to this 53. So all you need to do is just click on this button that says memtest. And you also see right there, there's another feature that I think Alex talked about at the beginning of the stream, where all Z590 series motherboards have resizable bar support. So if you want to be able to, of course, be able to take advantage of that, we've got a one-click button that's available to you. So to do the memtest, you're just going to click that button. And from there, it will reboot into the actual loaded module. And there's even a benchmark module that's inside of this. So again, this is kind of the premium experience that you get with ASUS and ROG, is that we are giving you the ability that right off the bat, when you first build your system, even before getting the operating system, you can just check your memory, make sure that everything's working okay, create a baseline, and you're good to go. So you can run through the test. It already has a preset test parameter, so you don't have to worry about anything. You can see it registers all the information. And if I want to stop it, I can go and let me end the test. If I go over here, and you can actually then see you have a full menu here. So you could actually do things even like a RAM benchmark, right? So if you actually wanted to get some actually throughput testing, that's all built in. So it's a really, really awesome feature that we have directly integrated in, and just shows kind of like the experience that we want users to have when they buy an ROG hardware. That we're really trying to give you the best experiences that we can.
I know
we can even still maintain our.
Sorry, go ahead.
Oh no, we can still maintain our screenshot function. So not a lot of people realize this, but we have built-in screenshots inside the UEFI. I see a lot of people take pictures. They share our settings in the community, and I'm like, we have a screenshot button.
We
Just
have a
press
button
the
for that.
F12 key, and you can.
Of course, they've got an app for that. No, I sound absolutely ancient whenever I bring this kind of stuff up. But what we're able to do now in the UEFIs compared to where we used to have to tinker around and manually adjust settings like this in BIOS still blows my mind. I mean,
I was gonna say, back in the days, you couldn't even use a mouse in BIOS. It was like navigate through the keyboard. What?
Oh, Alex, you're gonna at some point I'm gonna have to actually disclose my age here. And my first home PC was an 8088. So let me tell you about DOS.
Did you hit the turbo button?
My experience in building home PCs predates turbo buttons, but it kind of seems like we could get back to that. I feel it would be totally appropriate to have giant red button on desk. What make PC go faster?
So all we need to do now is I've entered back into the UEFI. I exited for some of the mem test. I just need to go to AI Overclock Tuner, and I'm just going to go to XMP. Nice. And we can see right there that now it's loaded our XMP module. So you can see right there, 5333. So that is now the loaded really frequency. Pretty. And just some other things. Remember, we talked about the beginning of the stream, Intel's ABT technology. It's an option right there. You can just go ahead and toggle it on. Our last demo after this will be our overclock demo, and then we'll be wrapping things up, guys. But one thing you can actually see right here already as a precursor to this is you can see our AIOC technology already working right here, where it does give you a full breakdown of actually what the CPU is indexed for. It gives you a cooler score that is based on your cooler, your CPU sample, and it can tell you that we actually can target this 5.3 gigahertz overclocks, the cache frequency, the load line calibration. We do AVX offsets. And a very important thing that I will note is we do use an adaptive vid voltage. And what that essentially means is, Alex, I'm sure, can probably give a little bit more insight into this as well. But an adaptive vid is really the gold standard. It's the best way to manage voltage for the CPU. Many overclockers, they use a kind of a more archaic voltage option, which is a static or a manual vid. And that means that the voltage essentially stays constant. So if I boot into the operating system and I'm doing 0, my frequency, let's say, is like at 5.1 gigahertz, but my voltage is not going to drop. My CPU frequency, it's not going to drop. Our auto AIC implementation allows the actual CPU frequency to dynamically ramp up and down just like it normally would. And we also manage the actual voltage in the same fashion so that when you're doing nothing, the voltage will come down. And then, of course, also when the actual load goes up, the voltage will go up. And in addition to that, the AVX offset is very important, because if you go from one very standard application like a game or your browser to, let's say, like Adobe Premiere, where you have AVX that might be coming into play, then we can actually slightly bump down the frequency to be able to ensure the best stability under that overclock scenario.
Yep. Yeah, those are all pretty cool features actually coming in with this generation. Like the AVX. Actually, you can also turn it on and off if you really want to, depending on what you're doing. And yeah, also the AVX deciding how many offsets you want to go into, like JJ was saying, for the stability of the overall overclock.
So I mean, I think that that's become one of the most crucial features for a lot of enthusiasts. Yep. I mean, maybe not the hardcore extreme. Right. I'm looking for records or to win competitions, overclockers, but the sort of daily. It's so funny that I'm trying to break this down into categories when we're talking about high-end desktops. You know, like, oh, the daily driver overclockers.
Yeah, exactly.
The bread and butter overclocker. But seriously, I mean, like, these performance curves are now so dynamically.
Actually, talk about performance curves. JJ, you guys also have implemented the VF curve features, right?
Yes, so we do have actually pretty much, if Intel has options available for our overclocking enthusiasts, we fully support Intel in terms of giving you all those rich options.
Awesome.
And so you guys can see right here, I've gone ahead and booted into the OS environment. You can see that pretty much it just applied the XMP profile, and right there we are running at 5.3 gigahertz there on the DRAM. So a really impressive feat that really anybody that knows overclocking, this is something that just wasn't possible in the past. You just did not see this type of streamlined DRAM overclocking capabilities. And you can even see right here, if I go ahead and load up the memory, I do a little bit of a test. You can see I'm fully loading up the memory profile. So I'm loading up that 5.3 with 100% CPU load. So this is pretty insane. I think Alex can appreciate this. Any overclocker can appreciate that we literally just went in, we dropped in this DIMM, we clicked a button, we restarted. I'm able to boot into the operating system, and to be able to be running at that, you can see right here we're following Intel stock values. So under full CPU load, all our cores, we're running at the 4.8 gigahertz and then 53. And to kind of just show everything off, we're going to go to our last point, which is just enabling AIOC to even go even further. But I think it's pretty impressive. I mean, what do you think, Alex?
No, yes, please. Can I have 2 of those?
Yeah, I would definitely agree.
I think it's awesome. I mean, because if you're back in the days on an overclocking, it was a lot of rebooting. Like changing rebooting again, changing out. Now it's so easy with all the different options like the motherboards have here, like the one from ASUS, and also the XMP profiles and all the different features. It's just like, oh, you guys said overclocking was very difficult. You just have to go click 2 buttons and we're done. It's like, we have come a long way.
Well, and not just making this more accessible, because to me, one of the concerns that I think I always had was this the general fog of fear over the silicon lottery.
Exactly.
What binning were you going to get? And now, and this goes back to your point, JJ, about making this a more holistic approach to building your PC. This is now much more dynamic and much more intelligent at kind of testing the limits of your PC and then finding those optimal performance curves, those optimal power curves, making sure that this stuff is dynamically addressed, rather than, like you were saying, Alex, that dance that we used to do. What binning did I get? What tier of processor? Exactly. Did I get lucky on this one? Let me reboot my system for a weekend to see how far I can push it. It's incredible to me. I mean, again, this still kind of feels like magic, that what we just saw on camera, like in real time, is sort of the starter process to get up and running and actually maximize the investment that you just put into your system.
So, yeah, no, you're 100% right. And that's really our goal. You know, we've tried to keep evolving the features. And I will also tell you, a lot of the work that you see here is literally years, and actually almost maybe to a degree, a decade work of close work with Intel. You know, our lead engineer and R&D team are lucky enough to be able to go directly on site to Intel's performance lab on a yearly basis during development cycles, and they work really, really closely. And this is an important distinguishing point for us, that we really commit to a large amount of effort to coordinate with their R&Ds and their architectural engineers, so that we can kind of collaborate and go like, what knobs and switches are going to be here, so that we can go back to our board and tailor our designs, and we can expose these knobs and switches. Many people don't kind of understand this, but it is actually critical that this kind of close collaboration is present very early on, to be able to expose all these knobs and switches. While not every user is going to utilize them, there's literally years of work that have to be put in by Intel's engineer team, the firmware development team, and then our board design team and our UEFI team to ultimately realize this, so that you have a knob or a switch inside of the UEFI. And that is directly based off of community feedback. And so I will say that that's one thing that we're really excited about, is that things like, you know, being able to do the VF offsets, the VF curve, so many of these different things directly came back from years and years of our users going, we would love to see this type of overclocking option. We would love to be able to see this type of option, this type of option, this type of option. And that's what we're seeing. So the evolution of this, and the last part here, is going to be our AIOC demo. So this is now actually, we've had for a couple of generations, and this is our most advanced version. And there's literally thousands of hours that went into this implementation, where we literally have to sample hundreds of CPUs, hundreds of cooler permutations. We have to track all the corresponding voltage tables for the different frequency targets, but ultimately to give you a really easy experience. So how does this work? It's simple. User installs their CPU. They put their cooler. My cooler that I'm using right here, this is a Strix LC 280 millimeter cooler. So nothing crazy, a standard high quality AIO cooling solution. We do recommend that you go into the OS and you run a stress test for like 30 minutes or an hour, or you play a game for 30 minutes or an hour at stock. What we will actually do is we will track your temperature. We will track the cooler's performance on a hardware level. We will log this information, and then we will create a cooler score. This cooler score then will correlate to the CPU frequency that we dictate. Of course, we don't want to give you an aggressive overclock if you've got a basic 120 millimeter AIO. Or if you have a custom water cool loop, you might have better performance. So that will adjust accordingly. And one of the really cool things is that this actually adjusts so much that even if your cooling performance goes down, so maybe like from the winter to the summer, the ambient temperature goes up and cooling performance maybe goes down, we can actually dynamically bring down the clock frequency, because your cooler score will actually go down. We'll notice that your actually cooling performance is not going to be as good. So all you need to do, well, just go over here to this AIOC guide. And when you go to the AIOC guide, you'll see that we explain everything. If you really want to understand all that works, how it's doing everything, you can see all the different tabs. We give you all the information, a breakthrough on how it's all being applied, right? But
I love that this is all in the UEFI.
Yeah, you click the button, click yes, and from there, you'll actually see now that it's automatically set this up for us. So you can see it says auto let BIOS optimize, right? And if you wanted to actually see what is going to happen, you can go into our AIOC technology feature, so AI features here, and you can actually see right there that it's going to tell you the P0 frequency, P1, core loading, adaptive voltage, and it's going to shoot for 53, 51, and 50 all core. So that's some pretty monstrous level overclocking that you're going to be able to get out of the box, right? And if you want to customize this, you can. You can tell the cooler to keep training if you want to. If you don't want it to keep tracking your cooler, then you don't have to. And if you also want to change the algorithm or maybe make it a little bit more conservative, then you can also just go in there and you can reduce the optimism scale. So we give you a lot of options. Even if you're a manual overclocker, then the options are here for you to go and do it more manually. And even if you wanted to dial in every single value manually, use our reference prediction table. The table's there for you. This is much easier than you having to go into a Reddit thread or watch, two
Yeah.
videos and try to figure out what's my target frequency, what's my AVX offset, should I be using this voltage table, what's my LLC parameter that I want to use. This is a baseline that you can use right off the bat. So you saw I literally just clicked one button. From there, I'm just going to press F10, and we're going to press OK. And that's it. Once we do that, it will now reboot. It's going to go through a little bit of a training process. So I'm going to just toggle back here for a moment and let it get ready to boot up into the OS environment. But it's a very simple process. And the cool thing on the AIOC feature, it is available on all the Strix boards. So even again, if we go back to something like our more entry-level ROG Strix board, this is going to still come with AIOC. The Maximus, of course, Hero board is going to come with AIOC. The Maximus Extreme that we're running this on comes with AIOC. And our Prime Series boards also do come with AIOC. So a very large amount of our lineup is all going to offer this really, really great feature.
Now, I mean, and Alex, to kind of tie you into this here a little bit too, this is a big day. We're seeing benchmarks, we're seeing reviews starting to hit the net. It's things like this that I feel are some of the hardest to quantify when I'm just looking at charts and graphs and little bar graphs of performance from generation to generation around competing products and stuff like this. Because it seems to me, as we're pushing forward on this platform, one of the major considerations is the consumer that's building a system and living with it, not the consumer who's throwing a different processor into a motherboard every other week to spit out some bar graphs. And it's this kind of fine tuning that I feel is the next generation of high-end desktop.
Yeah, I completely agree. There's so many knobs, and within every generation of processor, we're trying to bring more knobs, trying to give users more tools to fine tune their system to whatever uses they're using it for, whatever they want to use it. Because this is a tool at the end of the day, right? This is what we want to provide you, all to improve your tool, depending on how you're doing, even if it's for gaming, for content creation, for video editing, picture, all those different things, even if it's for high frequency trading. So all those different tools they want to provide you so they can actually fine tune that element. And that's why we work very close with ASUS and the partners, right? To make sure that we provide all the best for you guys, and also try to make it as easy and obviously we always want it to be as stable as possible. But sorry.
I was just gonna kind of shoot this back to JJ because I think he was ready. But I don't know if you remember, JJ, that conversation we had. It was like 3 years ago, where I was smashing my head against the wall because I was trying to quantify battery performance on a smartphone. And you're like, if I go super granular on like power thresholds, then it's not really, it's not information that like a smartphone consumer is really going to be able to digest. But if I dumb it down too much, it's not valuable, because like I would be testing in a way that no one would ever use their phone. And to me, it's always that part of the conversation. Like, what you're showing me right now is the next step from just, well, I ran this benchmark and I got this score out of it, and I got, I ran this game and I got these frames per second. That's like the beginning of a conversation about a premium desktop experience. It's not where we stop.
And I think the main thing that we're ultimately trying to achieve, which I think is the same goal for Intel, right, is our goal here is to afford users the flexibility to have the choice in how they want to pursue the experience for their system, right? That's really what our goal is to try to give you the option so that if you make an investment in a better product, better cooler, faster RAM, you can try to really realize those benefits, right? And that, whether that's going to be in gaming, whether that's going to be in content creation, whether that's going to be doing both, we just want to try to help to make sure that experience comes through more easily. And so you can see here, I'm now at the desktop, and the cool thing that you'll notice is right there is I'm letting the CPU idle, right? And I'm doing that for a purpose because I want you to see that the CPU is still idling correctly. So we're at 800 megahertz. The voltage is actually dropped down. And then, of course, it's going to be dynamic because things are going on, right? Little flitters here and there. But the whole point is that we're not fixed at a high voltage. We're not fixed at a high frequency. It's dynamic. And so now at this point, the next step would be something like, we're just going to do a quick test here just for kind of general reference. So this little utility actually allows me to go ahead and do some cool things like actually check the load in different configurations. So one, you can see right here, if I do load one, I'm just going to load just one thread. And so I could also bring up Cinebench, right, which would also work, but just for kind of quickness of purposes, I'm just going to do this. And you'll see that if I load it up, you see right there, it already peaked up to the 5.3. And of course, it'll vary a little bit because there's still power parameters that we have to follow from Intel's guidelines in terms of what's been defined. But you can see right there that it worked correctly. It peaked up to that 5.3. So you were able to effectively get essentially that overclock by doing what? Clicking one button. And you can also enable this AIOC feature within our software. So within Dual Intelligent Processors, which is within AI Suite. So you can actually just click this button if you didn't even want to go into the UEFI. And we actually do give you a little report tool, which also gives you this information in the OS. So it shows you right there that what our target was 53 on 1 core, 2 core, 3 cores, 51, you can see right there on 6 cores, and then 50 across all cores, right? So that's really impressive implementation. And again, here, if I went back out and loaded that up, right? So here, we can go ahead and do this. And you can see we can load it up, and you're now going to get the 5 gigahertz essentially across all the cores.
Nice.
So
that's really pretty. I just
yeah.
So a really easy option in terms of ultimately getting more out of your system, right?
Yeah.
So that pretty much wraps up, at least from my end. There's even more that we haven't talked about. As always, that we've got a huge amount of specifications, features, and functions. If you guys definitely have more questions, I'd love for you guys to come join us in our PC DIY Facebook community. Check out our EdgeUp website, edgeup.asus.com, where we've got guides and breakdowns on our series of motherboards. And of course, we've got tons of other things out there to help you, to give you kind of a better understanding of our boards and our feature set. But hopefully what you're able to see here is that, if you want to be able to upgrade to an Intel 11th gen, you've got a board that's going to be able to be stable, reliable, and really feature rich. You're going to be able to pick a board based on your aesthetic, whether it's going to be black or whether it's going to be white. You want to go RGB, go RGB. If you don't want to go RGB, you don't need to go RGB. And we've got a really great set of options, right, from networking to audio to overclocking, right, to get you covered however you're going to use your build, right?
Nice. So
Awesome.
I mean, I've got like a little teaser question here, but we're kind of coming to the close of this broadcast. Between the two of you, JJ, Alec, specific pairings. What are we thinking for processors and boards? Kind of stapling some options together, because it looks like we're pretty well covered for, sort of consumers at varying tiers and with differing needs.
I think for me, I don't know what Alex's thoughts are. I mean, segmentation-wise, I think i5-wise, my recommendation is if you go with an i5, it's going to be going with our TUF Gaming. So I think our TUF Gaming is really solid in terms of the budget standpoint. So that would be for me, TUF Gaming or one of the Prime Series motherboards. If you're going to go i7, I think you should step up to something like the ROG Strix series. So that's going to be this guy. So the Dash A, which is in white, the Dash F or the Dash E. And then if you're going to go, of course, i7, i9, I think you want to go ROG Maximus. Go with the Hero, go with the Apex, go with the Extreme. But again, I'm going to go back to, what I said there from the very beginning, that even if you got something like our Prime series, our Z590-A, and you wanted to run an i9 in this, the power delivery design, our teamed power stage is very, very, very strong, and we have very good thermal solution that I have no qualms about saying that you could run stably and reliably without any issues, even if you wanted to run an i9 in this board. So those would be my pairing recommendations.
Actually, I was very, very impressed by all the features that they wanted you to show has. I was like, wow, that's the quote unquote entry. I was like,
starter.
Exactly, the starter kit.
I wanted to show, one last thing here that I thought was kind of cool. You guys might appreciate this. It's a little bit of an off angle, but the Extreme board does also have this ultra large integrated live dash display. So it's got a cool little readout that you can customize, so you can see your voltage, your frequency, your temperature, your current. It's all integrated on there, so it's a cool little display that we have on the Extreme Series board.
I over under on how long it takes someone to start playing Cyberpunk from that display. What are saying the Vegas odds?
Let's start taking bets.
Right, and directly from the UEFI, because apparently it's a full computer all on its own before you even load an operating system. I love it. All right, yeah, we're kind of coming to our time here. We actually ran a little bit longer, and I'm really glad to have you both on this stream just to kind of help us talk through all of these products, these announcements. We've been seeing a lot of chatter in the chat. That was a terrible way of saying that. But folks, we're curious who pulled our prizes for this 11th gen 11 processor giveaway. I'm just going to list out the names here really quickly. John V, Corey R, Brad M, Arash E, Nima F, Thomas L, Vincente F, Christopher N, Kevin B, Eric D, and Fernando C. Definitely be in the lookout, as someone from Newegg is going to be contacting you about scoring some great new hardware. It's going to be a really exciting processor, and a few of you are going to be getting a processor and a motherboard coming your way soon. So some really exciting stuff there.
Congratulations to the winners.
Yeah,
I was very stoked.
Yeah, and again, thank you for everybody that's been jumping in on the stream and checking out what we're going to be doing here. JJ already talked about the DIY community that ASUS has been building. Please give them a follow. It's an amazing resource, and some phenomenal conversations are happening there about high-end desktops, and then also getting more people into this enthusiast space. Well, that's the accessibility part of this is we're kind of in a renaissance of PC building, home computing, and more people are getting interested in this. And it's just nice to have great ambassadors to bring people into this community, kind of refresh our ranks a bit. And those types of resources are invaluable. And to also not only for your own education, but to help contribute, so that you can be a part of this community and that you can also bring more people into the fold. I always feel is kind of a special superpower that we tech geeks have. And then Alex, you're going to be doing something tomorrow. I want to make sure we highlight that too.
Yeah, that's correct. So tomorrow we'll be doing an AMA on Reddit. On the subreddit will be Build a PC. So we're going to be there for the majority of the day. We'll be starting at 8:30 a.m. Pacific time till 3 p.m. if I recall correctly. We'll be there answering questions with regards to how to build a PC, any questions about tips and tricks. We'll also be answering any questions that you might want to ask with regards to the Intel 11th Gen desktop core processor. It's an AMA, so you shoot, and we'll do our best to answer, give you a direct answer, an honest answer. That's where we want to be there. And yeah, more than happy to have you there.
Excellent. All right. Well, JJ and Alex, thank you so much for joining. And again, just to kind of, we're hoping to eventually start holding these types of events in person again, getting you back into the studio and also get lunch or grab dinner after one of these events. So especially from the Newegg team here, I hope everyone on your respective teams at Intel and ASUS, and then also all of your family and friends, that they've been okay during these very challenging times. But we definitely appreciate you taking the time to jump on our stream here today.
Yep, and I want to thank everybody for joining as well. I wish the best to all of you. Stay safe, stay healthy, and I look forward to you guys' comments. If you have any comments, feel free to go ahead and drop them when you go ahead and hit a sub for this channel, because we love working with Newegg, and they've got tons of great content, so make sure to go ahead and sub to them. But feel free to go ahead and tag me. I usually try to follow up for the next few days. If you guys have any questions or comments on anything that we presented in the stream, I'd look forward to be able to follow up with you guys. So thanks again for having me. Take care. Take it easy.
Thank you, guys.
Yeah, and again, JJ's real good with the replay crew. So if you're not catching this live, that was legit. He is going to be helping us out in fielding these conversations. So everybody, another huge thank you everyone out there that's watching, that is joining us on these geek and tech conversations. And don't forget, click the links in the description below. You can find all the products that we've been talking about today, all of Intel's new 11th gen processors, all of the new ASUS Z590 motherboards, all of the information on Newegg. Make sure that you're a part of this conversation. So folks, I'm gonna sign this off now. For Newegg Studios, I'm Juan Carlos Bagnell. Thank you so much for watching, for sharing our videos, joining our live streams, contributing to the conversations, and I'll catch you all on the next video.